Everyone, I'm Won Lee. I'd like to introduce a little advanced concept, partial sum of square, partial f, partial r square. Okay, you know sum of square, f statistic, and r square, but we are now want to know partial sum of square, partial f, partial r square. It is a little advanced, maybe uh, complicated, but it is just simple and easy to understand. Let's see. The concept of a partial sum of squares and partial f value are necessary to understand variable selection. This section is just the next section, 8:14, that will be discussed later. Suppose we are considering uh, a multiple linear regression model, including p explanatory variables. The partial sum of squares, partial SS, is the increase in the regression sum of squares, okay? Amount of increase in SSR when the remaining p minus 1 explanatory variables, excluding a specific variable xj, are enhanced by adding xj. Oh, that is a long comment. So they are x1 up to xp, p many explanatory variable. You exclude one of them, just xj. Then remaining p minus 1 explanatory variable in the model. You can get regression sum of square, SSR, right? Finally, you add xj in the model, then you will get SSR full model, say p explanatory variable, right? Explanatory variable. So x1 to p SSR x1 to p full model, you are considering p explanatory variable minus SSR except xj, right? x1, xj minus 1, xj plus 1, xp. That is increase of SSR, we call partial sum of square xj. Get it? Okay, if the partial sum of square of xj is large, this one is big, then finally included explanatory xj is important. That means statistically, say, significant. Okay, it indicates that the explanatory variable xj should be included in the model. Does it make sense? In other words, when testing hypothesis, this one, we studied test hypothesis of each coefficient, right? We already seen it, this one. The tested statistic is called partial f value, which is defined as partial sum of square of xj divided by what? Mean squares error. Sum of squares error divided by n minus 1 minus p. They are p explanatory variable and plus 1. 1 is what? Beta 0. They are p many explanatory variable and 1 intercept term. So they are actually p minus 1 what? Parameters. So n minus p minus 1, n minus 1 minus p. Okay? That is degrees of freedom of residual sum of square. We studied this one, 8 section 6, ANOVA table. So it is just simple. It's not bad test statistic for this hypothesis. Okay, the partial sum of squares is also used to calculate the partial determination coefficient. Partial. For example, suppose there are two explanatory variables, x1 and x2. The partial determination coefficient of x1 indicates that how much more y is explained by adding x1 to the part not explained by x2 when x2 is used as the only explanatory variable. In other words, SSE of x2, okay, you take x2 first in the model, x2 first in the model. Then there are two explanatory variables, x1 and x2, okay? You take x2 in the model, and then there is unexplained variation that we call SSE x2. And when you add x1 in the model, that is what? Partial sum of the square of x1, right? So what is the proportion ratio of partial sum of the square of x1 to unexplained variation of x2? Get it? That is partial determination coefficient of x1 for the data y. So r square y and x1 given dot 2 notation. This is a notation. Somebody denotes it like this, bar. Okay? SSE, the partial sum of square of x1 divided by SSE x2. So what is the ratio of increase of SSR partial adding x1 is out of unexplained residual sum of square of x2, only x2. All right, next. Vice versa, of course, the partial determination coefficient of x2 for the data y is defined as follows. Now, you first will consider x1, x2. You first include x1 only in the model. There is SSE of x1. So, adding x2 in the model later, then you get partial sum of square of x2. This is an increased amount by adding x2 in the model. We call the ratio, we call partial determination coefficient of x2, say r square y and the 2 first given x1. Get it? Which is a ratio of how much more y is explained by adding x2, okay, to the part not explained by x1 when x1 is used as only explanatory variable, that is SSE of x1. Okay? Now, let's consider a case of three explanatory variables, x1, x2, and x3. Now there are three explanatory variables, x1, x2, x3. The partial determination coefficient for x1, okay, for x1 is, say, y and 1 given x2, 3. It is not actually given, but previously x1, x2, and 3 in the model. Okay, the partial sum of square coefficient for x1 is the ratio, the partial sum of square of x1. You know x1, partial sum of square of x1. Okay, increase x1 is increase amount sum of square, residual sum of square. This one, okay. Within SSE x2, x3, obtained when performing regression analysis with only x2 and x3. You take x2 and x3 first in the model, then there is residual sum of square of x2, x3. Okay? So, and finally, you add x1 in the model, finally, x1, x2, x3, all three explanatory variables in the model, then there is partial sum of square of x1, right? So what is the portion ratio? Partial sum of square of x1 to residual sum of square x2 and x3 that we call partial determination coefficient for x1. Get it? Oh boy, it is not complicated. It is just simple, but terminology seems difficult. That's it, I think. Okay, we will go to variable selection with this concept, partial f, next time. Thank you. Bye.